Okay, guys, we're back on packet number 5. This is question 6. Let's see. So what is the maximum value of the derivative of f of x? Okay, so this tends to confuse a lot of students. If we're talking about derivative, we're talking about f prime of x, right? And we can go ahead and find f prime of x right now, which is 6x minus 3x squared. And now they want the maximum value of this derivative. You want to maximize it. We're going to max this, which means you need to take the derivative of this. So essentially you're doing a second derivative. And I'm just realizing how poor this quality is. Interesting. Anyway, okay. So we're going to take the derivative again, which is going to be f double prime of x, which is 6 minus 6x. And then to find the critical numbers, we set it equal to 0. Move my mouse. And we're solving for x. So it looks like x equals to 1. So on this value, if I did a second derivative line test at 1, we get a positive and a negative here, up, down. So great, this is going to be where our maximum value occurs, right? So remember, this is the location of where my maximum slope occurs. They are asking for what is a maximum value, not where it occurs. We're actually they're asking for the maximum value, which means I need to substitute x equal 1 back into my maximum value derivative, back into my derivative equation, which is this right here, right? So I have f prime of 1, which is going to be 6 times 1 minus 3 times 1 essentially, which I'm going to get a value of 3. So it looks like choice D is my correct answer. Okay. I already did next question number 7. I already did this one. I'm just going to walk through with it. I don't think I recorded it. I can't find it if I did. So here we go. Number 7, let f be a differentiable function for all x, which is the following must be true. Okay, so this is all fundamental theorem calculus. And so the first one, if you forgot the fundamental theorem calculus, you can take the derivative, the integration, and then take the derivative of it individually. So this one, the first one right here, this is the integration from 0 to 3. You get, I use capital F as the integration of lowercase f. So I have f of 3 minus f of 0. But you're taking the derivative of this. You still haven't taken the derivative yet. And since these are all just numerical values, well, then derivative equals to 0, not f of x. It equals to 0. So that's gone. And I did the same thing here. You guys can pause the video and look at my solutions. This is my work going from here. Doesn't equal to f of x. They're missing this part right here, f of 3. And the third one, this is the straight up the fundamental theorem calculus definition. And I'm having some technical difficulties. You guys didn't see anything I was talking about. Well, there you go. And so I just did this in case you guys forgot the fundamental theorem. And then I actually worked out the problems, worked out the solution. But you should hopefully remember the fundamental theorem calculus is just f of x on the bottom. So number 3 is the correct answer, which is what, B? Letter B. Okay. Okay, so number 10 on packet number 5. How many points of inflection does a graph blah, 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 blah have? Okay, so I need to find the second derivative, find the critical numbers, and then see if it changes to positive, negative, negative, positive, that kind of stuff. So I'm going to go ahead and find the first derivative. I'm going to call it y prime, since they called it y. And it looks like I get, what is that, 12? I think that's a 2x to the 6th power. So 12x to the 5th plus 45x to the 4th plus 40x to the 3rd minus 1, and then plus 0. And then we're going to do that one more time to find the second derivative. You get 60x to the fourth plus 180 x to the third plus 120 x squared. And now I have to set equal to 0 to solve for x for my critical numbers, right? And I think I'm going to use, obviously, GCF first. I could pull out a 60x squared from everything, and I'm left with just an x squared on the inside plus 3x and then plus 2, so equal to 0. That's not bad, right? This is 60x squared. This one I could factor to x plus 2, x plus 1, and that's nice. I can say x equals to 0 and negative 1 and negative 2 for my possible inflection points. These are my critical numbers. They could be inflection points. I'm not sure. We still need to do a second derivative test to see if they change the signs. So I have negative 2, negative 1, and 0. And if you did the test, I believe you'll get a plus here, a minus here, a plus here, and a plus here. So it looks like it changes directions at this guy and at this guy, but not at 0. It remains positive plus plus, right? So my points of inflection would be, I have 2 points of inflection, which is choice number C, or letter C. Okay.